one. Okay, so this is what has been mentioned. So this is a rectangular enclosure. So annulus with 0.2 here, here it is 0.3. So the more and more the curvature, that is the radius is increased, so you see more heat transfer. Okay, so the effect of the concentric insertion of a solid cylinder is to increase the heat transport. Okay, this is a very important thing. You just insert one cylinder, you can achieve a higher heat transfer. Okay, so this is what you have. Now, I told you that we are studying the dynamical system in this problem. And so we came across the 5-mode Lorentz model. So if you solve the Lorentz model for very high value of the Rayleigh number, thermal Rayleigh number, you'll see that this plot for the maximum Lyapunov exponent crosses this axis, the R axis, and this is indication of the onset of chaos. Now, so the Hop Rayleigh number is 28.7 in the case of a cylinder. It is 24 in the case of the rectangular enclosure. So and there are many things here. Once the maximum Lyapunov exponent increases at certain points, it simply dips like that and tries to reach the x-axis. So these are points at which you might get periodic motions. So a lot of things can be said regarding that is chaotic motions. So this is a bifurcation diagram. Wherever you saw in the dip in the curves, you see these spaces. Okay, there is nothing over here. These are called as windows of periodicity or limit cycles. So if you plot the solution of the dynamical system, you will see that they go around in circles. It may be a 2-cycle or a 3-cycle or a 4-cycle. So these are all characteristic features of chaos, that is. So what you study in the case of a rectangular geometry, you can study much more, much better in the case of a cylindrical geometry. In the case of annulus, you see that the Hop bifurcation, Hop